So I want to do a quick video talking about the robots because I feel like I've neglected them on YouTube a little bit. It's just easier to do a TikTok style of a video rather than this format. So apologies for the shaky cam. I am on my phone, but this is SPG, or Special Patrol Group. It is a Beetleweight version of tank, which you might have seen if you've seen any of the other content about these. And just for scale purposes, this is a Beetleweight. This is an Antweight, and this is the US Antweight. So these are Americans call them ferry weights, is what the UK follows. We follow the US one. So these are 400 grams in weight. The other ones can be a lot smaller than that. They're like 150 grams. I believe I've got one sitting here somewhere. Let me see. No, I don't. I don't know where it's went. Okay, I did have one, but yeah. So it's a little bit bigger, but so this is the Beetleweight. So this is up to 1.5 kilograms in the UK. Americans, they do £3, which is 1.3 kilograms ish. So about 1.5 kilograms. It's got 4 brushed motors. These are 1000 RPM, and they're a little bit too fast. I would have liked a lower RPM so that it's more torquey, but the biggest downside is going to be these wheels. So these wheels are, this is too big, but these wheels are printed, 3D printed in TPU, so they're not the grippiest. But they do have a decent bit of grip, but just they could be better. So I think that the speed isn't going to hinder it as much as the lack of grip on the wheels. So I'm going to put some rubber bands or things like that on them just to give them that little bit of extra grip. But yeah, so they're a bit quicker than what I would have liked, but we've got 4 of them, so it's a 4-wheel drive. We've got TPU side armor, so it's flexible side armor, so if something hits it, it just bends. The front is poor man's composite armor, really. It's 2 thin aluminium plates bolted between a thing of TPU, so you can sort of see the TPU in between there. The metal itself is fairly thin. It's came out of an old bread tin that I've cut up. And so we have that on that side, and then if we flip it over, we have the same on that side, and it's designed so that in this sort of angled shape, so that if it flips over, no matter which orientation it's in, this bit, the bit that's sloped down, is always the front. So that is always forward on the control stick. So if it flips over, that is then forward on the control stick, just to make it sort of easier to identify. And then on the top, we've just got acrylic. Now this isn't great. Ideally I would like to use polycarb, just because this stuff cracks and shatters rather than just chips. So what polycarb does, it's also quite thick. So I'll probably replace that at some point, but at the minute we don't have to worry about weight. We've got our on-off switch here. Something I do need to add in is a slightly more visible LED. There is an LED on the motor controller that you can see in there, the dual one, but just I want to add a bit more of a brighter light in there so that it's easy to see. So that's the Beetleweight. But the next one up that we are working on is exactly the same design, but the Featherweight. And for size comparison, that is the motor for the Featherweight. So substantially bigger, so much so that I can't 3D print it. This chassis was all 3D printed, and I had to send this to a friend of mine to get printed, because my 3D printer is that one, the Bamboo Labs A1 Mini, and I needed a bigger area to actually 3D print the chassis for this one. It's just 3D printed in PLA, so it's not the strongest, but I think it should be fine because it's quite thick, so we'll see. But the Featherweight is big enough that I can't reasonably 3D print it. Even if I did it in sections, it would still be too big. So I'm going to get some HDP sheets. I've done the design up in CAD. It's basically the exact same design as this, just bigger. A couple of key differences is it's going to have a brace plate going across on the bottoms underneath, and that's what the motors are going to be mounted to. So I've 3D printed these mounts. These are in TPU as well, so they're nice and flexible to absorb any vibrations, any shocks. They'll get absorbed by that. It does have a couple of screw holes on the front there, hopefully you can see. So the idea being is that it will be screwed into the wall, so effectively this bit, So it'll be screwed into there. This bit will protrude out, which the wheel will attach to. The frame will come to about here. TPU pieces, and then these will screw onto the cross brace that, as I say, is going to go basically straight along the bottom underneath those. And then I'll be bolted to those, and then we'll have the wheel attached there. Haven't decided on the wheel yet. This was a prototype of basically these wheels, but bigger. I'd need to double the width to match sort of the standard wheels that are out there, but I don't think it's going to be good. So I printed this with a really low infill so that it's nice and it's squishy, so that, you know, hopefully whenever it's laid down it'll be have a bit more surface area. But I don't know, I think it would be better to 3D print this to make a mold, to then mold it in a better material than TPU. So I might do that. I might just buy the wheels. They're really not that expensive. I think about 40 quid will get me 4. And I know that they fit quite nicely. They'll screw straight onto this. And then we've got these screws here that go into basically hold them in place. So I might just do that. But yeah, so the big one, once I get it done, I'll be doing more videos on it. It'll be mostly HDPE and then probably some form of metal for this front armor. I also need a name for it. So far I've been calling it Vivian, just old reference. In fact, if you understand that reference, you should understand the Vivian reference. But yeah, on these motors are a lot better than these ones for what I wanted out of the bot. So this one is it's out of a drill motor. I've got 4 of them. So you've obviously seen that one, and I've got 2 more in here as well. But it's much better for it because it's a 2-speed gearbox in here. So you can adjust this here by putting that either that way or that way. And it's either a high speed or a low speed. I've got it on low speed at the minute, and it's an 18 volt 18 volt motor. But if I actually just do this, and I can show you it spinning, maybe. So if I power it on, it's hooked into the bench power supply at the minute. This is going to be loud. And with no load on it, it draws about 2.3 amps. So on load, it's probably going to be up to 5, potentially, depending on... well, actually, the gearbox in there might take it fine. We'll see. Either way, it's going to draw a decent bit of amperage. I actually think this controller could potentially handle it, but I'm not sure. But yeah, it's got the low speed, so it'll be nice and torquey. So it should be good to go. So yeah, I'll be doing more videos on this, hopefully, as long as I remember, as I'm building things. I need to get better at doing that. So yeah, if you want to see more, let me know. Or if you care more about the cybersecurity stuff, let me know that too.